So in this video we are going to be looking at special matrices, and there are some matrices that are some kind of special. So let's look at them. For instance, a square matrix is some kind of a special matrix of its kind, where you have the same number of columns and rows. So in the typical example, this matrix, let's call this matrix A. You have 1 2 3 columns, right? Then you have 1 2 3 rows respectively. So m is equal to n is equal to 3. There's 3 rows, 3 columns. So the same way for identity element. An identity element could also be represented as letter I. An identity element is represented as letter I, where all the diagonal elements are 1, but every other element is 0, right? Every other element is 0 except the diagonal element. So this could be found in a 2 by 2 matrix as well, where you have 1 0 0 1. This is an identity element. So at this level, this is all you could that could be obtainable, but in the higher levels you could also have identity elements of 4 by 4 matrix, right? And identity elements are of special matrices or square matrices alone. You can't have a 2 by 3 matrix that will be identity. There will be an identity element. So when we talk of identity elements, we only speak of square matrices, right? So it is also, well, when we get to determinant, we are going to look at that. But the determinant of an identity element is said to be 1, right? But then when we get to determinant, we'll look at that. All right. So before we get to inverse matrix, there are some other kind of special matrices as well. We spoke of the square column matrix. 1 2 3. This is a column matrix. This is a kind of a special matrix as well. And then we have a row matrix. We have a row matrix 1 2 3. This is only one row, so it's called a row matrix, and this has only one column, so it's called a column matrix. So these are some other kind of special matrix that we have. And there's another special matrix also referred to as matrix called the diagonal matrix. Diagonal. So when we speak of diagonal matrix, every other element is 0 except the element on the leading diagonal. But there is a difference between the diagonal elements and the identity element. Now compare. For the identity element, the only values there are 1s, and they are the diagonal element, the leading diagonals. But in the diagonal matrix, you could see that the leading diagonals are not necessarily 1, right? They are not necessarily 1. So there's a difference. Here in the unit matrix, all the leading diagonal are 1, right? All the diagonal elements are 1, but in the diagonal elements, in the diagonal matrix, the diagonal element or the leading diagonals are not 1. So we also have some other kind of special matrices, which refer to them as upper triangular matrix and lower triangular matrix. For instance, when we speak of upper triangular matrix, we speak of something like this: 1 2 3 0 4 5 0 0 0. So this is some kind of an upper triangular matrix. So how do we know this is an upper triangular matrix? Where we have this, you can see this is in form of a triangle, right? This is in form of a triangle. This is in form of a triangle where the upper elements in the matrix are not 0, but then every other thing down is 0. So in the same way, we can also have the lower triangular matrix in this way. This is 0 0 0. this is say this is 1 2 0 3 4 5. So in the same way, you could also see here, all right, you could also see a triangle forming here. Could also see a triangle forming here. Right, so this is the leading this is the lower triangular matrix, and this is the upper triangular matrix. So this is about our special matrices that we have. So in the next video, we are going to be looking at inverse of a matrix, which is very important. We're going to be looking at inverse of a matrix. Please like this video, share it with friends, and subscribe to the YouTube channel as well, and don't forget to hit the notification bell to get notified each time we upload a video. Thank you.